Okay, so let's unpack this. Today, we're diving deep into a frontier of AI that honestly feels like it's straight out of science fiction sometimes, but it's very much here and now. Multimodal AI and generative models. We've gathered, well, quite a stack of material for this, dive articles, the latest research papers, some pretty detailed notes, all exploring what these technologies actually are, where they came from, the really incredible things they're starting to do now. We're also looking at the cutting-edge developments, like what's happening right this minute, and also grappling with the very real challenges they bring up. So our mission really is to navigate this complex space together, really grasp the core ideas, maybe find some of those surprising facts hidden in the sources, and basically give you a shortcut to being seriously well-informed on this, well, frankly, exploding area of AI.
Yeah, and just to set the scene a bit, the really exciting shift we're seeing, and it's highlighted in the material, is AI moving past just dealing with one kind of data, just text or just images. Now it's starting to understand and even create content using multiple senses at the same time. It's getting much closer to how we actually perceive and interact with the world around us.
That's such a great way to frame it. So, all right, let's start by just getting a handle on the terms. First up, multimodal AI. At its core, what the sources are describing here are AI systems specifically designed to process and, crucially, combine multiple types of information. So we're talking text, images, sound, video, sometimes all at once. The goal, it seems, is to enable more advanced, maybe more natural, more human-like interactions. A simple example that keeps coming up is, like, you feed the AI a photo and it generates a detailed description. Or the other way around, you give it a text prompt and it creates a whole new image. It's fundamentally about linking these different forms of data, right?
Exactly. And what's really fascinating and sort of a key point is how this integration, this combining of diverse data forms, often leads to much more robust systems. You get higher accuracy sometimes in tasks we thought AI was already okay at, like image recognition or speech processing. It seems to leverage the unique strengths of each type of data. The material mentions IBM talking about data fusion techniques, ways to combine these modalities, maybe early on or midway through processing or even right at the end. And this fusion, it helps make the whole system more resilient if, say, some of the input data is a bit noisy or maybe even incomplete. It can kind of fill in the gaps.
That makes total sense. Yeah, it's not just relying on one stream, it's cross-referencing,
Yeah.
building a much richer picture of whatever it's looking at. Okay, so if multimodal AI is about understanding multiple data types, where do generative models fit into this puzzle?
Great question. So, generative models are, you could say, a powerful subset of AI. Their main job, their core function, is to create new data. These are the models that, well, many people have probably encountered because they produce things we can actually see or read or hear. Think about things like Delili, which can conjure up an image from just a text description, or those large language models like the GPT series that generate really coherent, sometimes surprisingly human-like text.
Right. And this is where it gets really interesting, isn't it? When you put these two big ideas together, the multimodal understanding with the generative creation power, that's where we get multimodal generative AI.
Precisely. It's the ability not just to understand inputs from different formats, text, sound, images, but to actually produce new content across those different formats too. So
Yeah.
you could input text and get an image, or input an image and get audio or some combination. These systems are learning the really complex underlying patterns and processes. This allows them to generate content in one format that accurately reflects information they received in another. They're learning how sight and sound and text sort of relate to each other in the real world and then using that to create. And, to really appreciate how significant this is, it helps to take a quick step back and look at the AI journey. We started ages ago with simpler rule-based systems, then came machine learning, where systems learn from data patterns. And then deep learning really changed the game with complex neural networks. Multimodal AI feels like the latest major frontier, built squarely on that deep learning foundation. For a long, long time, AI systems were mostly specialists, right? They were experts at text or experts at images, but putting those together smoothly, that was tough. It's the recent innovations, really powered by deep learning breakthroughs and these generative techniques, that have finally made it practical for systems to handle multiple types of information all at once. And it's a pretty big step because, as some of the analysis points out, this evolution, well, it actually mirrors human perception quite closely. We naturally combine input from our eyes, our ears, other senses to get a complete picture. AI is starting to do something similar, aiming for that kind of holistic understanding. Now, diving a bit deeper into the mechanics, the how, and also why this is so technically challenging. There's a paper reference from Carnegie Mellon that gives a useful framework. It highlights key characteristics of this multimodal world. First, The data types themselves are just fundamentally different. Text isn't like pixels, which isn't like sound waves. Then connections, how do these different data types actually relate to each other in a meaningful way? And interactions, how does processing one type of data influence how you process another? And this leads to some, well, pretty thorny technical hurdles that researchers are wrestling with. Think about representation, for instance. How do you take an image and words and represent them internally in a common format that an AI can actually work with together? Then there's alignment. How do you make sure the AI connects the word cat in the text to the actual cat in the image, not the dog next to it? Reasoning is the next step, drawing logical conclusions based on all this combined aligned information. And then, of course, generation, which we touched on. Creating new content, like an image or text, that correctly reflects information across these different modalities. You also have challenges like transference. Can learning from images help the AI process text better, or vice versa? And finally, quantification. I mean, how do you even properly measure how well a system is doing when it's juggling all these different data types at once? It really underscores the complexity running under the hood.
Wow, yeah. Those are some significant technical mountains to climb. And yet, despite all that complexity, the pace of development we're seeing right now, it's astonishing. The source materials are just packed with examples of new models and developments popping up constantly. I mean, we saw mentions of things like Microsoft's Fae 4 announced just this past March. Apparently, it's designed to process speech, vision, and text pretty efficiently, even on devices with, less computing power. Then Meta's Llama 4 was unveiled in April, building on their big language models to add more advanced multimodal features. DeepSeek VL is also right there in the mix, competing head-to-head with others like OpenAI's models. And speaking of OpenAI, models many people might know, like GPT-4o Vision, it really stands out for handling text, images, and audio, enabling these increasingly lifelike back-and-forth interactions. Google's Gemini 2 was designed right from the start, architected to be natively multimodal text, images, audio, video. Even though, yes, there was that temporary pause on its image generation capability for a bit.
Yeah.
And it's not just the giants. Beyond these, headline-grabbing models, we see specific examples like DLE3, focused on text to image. There's Elevate, an interesting open-source project merging vision and language. Pollen E from Google, which is fascinating, combines visual, textual, and even observation data from robots. Meta's ImageBind links 6 different modalities, which sounds incredibly complex. And OpenAI's CLIP, which is known for connecting text and images really effectively. And its impressive zero-shot learning ability, meaning it can often understand image categories based on text descriptions, even without specific training examples for that category. And just to put some numbers on this growth, SuperAnnotate estimated the market at, USD 1.2 billion in 2023, and they're projecting it to grow at a rate of over 30% compound annual growth rate by 2032. That's just explosive growth.
Yeah. Absolutely explosive. So, okay, how is all this incredible technical progress actually translating into the real world? This is where we see multimodal AI bridging that gap from the research lab to, actual practical impact across a whole range of industries. Yeah, the sources highlighted some really compelling examples. Take healthcare. Imagine an AI analyzing not just a medical scan, an X-ray perhaps, but combining it with the doctor's clinical notes, the patient's history from their records, all to potentially reach a more accurate diagnosis. Stanford, for instance, apparently has a model doing something very much like this, integrating notes and images to help personalize cancer care. That's pretty profound. Customer service is another area seeing big changes. Chatbots are moving beyond just understanding typed text. They're starting to understand the nuances in your voice, your tone, which could lead to much smoother, maybe more empathetic interactions. Companies like Unifor are mentioned as working in this space. Retail's using it too for more personalized shopping. Amazon Style Snap is a good example. You show it a picture of an outfit you like, and it uses that image to give you style recommendations. In security applications, multimodal AI can enhance threat detection by analyzing video feeds and the accompanying audio simultaneously. It gets a much fuller picture of a situation that way. And manufacturing, this one's interesting, using it for predictive maintenance, monitoring equipment using both visual checks from cameras and data streaming from sensors to spot potential problems before they cause a breakdown and costly downtime.
That manufacturing example really hits home, doesn't it? It's that aha moment. It's not just that the AI can see the machine or read the sensor data separately. It's that it can intelligently combine those two different perspectives, almost like a human expert would walk around a machine, look at it, and check the diagnostic readings. It's that fused intelligence that makes these applications so much more powerful and, frankly, feel more intuitive and useful. Now, it's really important we look at the flip side, too. With technology this powerful, this capable, well, there are significant challenges and ethical considerations that the sources rightly emphasize we need to be aware of and actively tackle.
Absolutely critical. One major area of concern brought up repeatedly is privacy. When you're dealing with multiple types of personal data images, voice recordings, text, the potential impact of a data breach increases significantly. Protecting that sensitive, combined data is paramount. Then there's the issue of bias. Bias creeping into the training data, whether it's visual, textual, or auditory data, can unfortunately get amplified in these complex models. This could lead to unfair outcomes, misinterpretations, or even genuinely harmful consequences depending on the application. And related to that is the potential for misuse. There's a growing worry, and it's mentioned clearly, about these powerful generative capabilities being used to create convincing deepfakes or spread misleading information at scale. IBM's point about rigorously stress testing these systems to find vulnerabilities before bad actors do seems particularly relevant here. And finally, let's not forget the complexity and cost we discussed earlier. Building, training, and running these sophisticated multimodal systems is technically demanding. It requires significant computing resources and specialized expertise, which can translate into high operational costs, potentially putting it out of reach for smaller organizations. The consensus in the material seems to be that ethical development, thinking about these risks from the outset, is absolutely crucial to steer this technology in a beneficial direction.
Okay, so looking ahead then, what's on the horizon for this field? What are the big trends the sources suggest we should be watching out for in the future?
Well, one significant trend seems to be the push towards unified models. So instead of having separate systems for different modalities or complex methods to kind of stitch them together after the fact, researchers are increasingly working on single monolithic AI architectures that can handle multiple modalities seamlessly right within that one model. The goal is more fluid, more integrated understanding and generation. Real-time processing is another area highlighted as becoming absolutely vital. Think about applications like autonomous driving. The system has to combine visual data from cameras, auditory cues, sensor readings, all instantaneously to make safety-critical decisions. There's no room for lag. And similarly, for the future of augmented reality, AR, and virtual reality, VR creating truly immersive and believable experiences requires integrating text, images, audio, maybe even haptics, all in real time, responding instantly to the user. Multimodal AI is key to that vision. And finally, the sources really emphasize the ongoing importance of open source initiatives. Platforms like Hugging Face, which allow researchers to share models and datasets, are crucial. Also, collaborations like those involving Google AI and other major labs are seen as vital for accelerating progress and, importantly, for collectively tackling those big technical and societal challenges we've been discussing. Sharing knowledge seems key.
Wow. Okay, we have covered a lot of ground today. A really comprehensive deep dive. We've gone from trying to define multimodal AI and generative models, tracing their evolution, looking at the cutting-edge models emerging literally right now, exploring their incredible impact across so many different industries, and also making sure to address the really important challenges and ethical questions they raise.
Yeah, to sort of sum it all up, multimodal AI and these generative models are fundamentally reshaping the landscape of artificial intelligence. By enabling machines to process, understand, and create content across all these different data types, sight, sound, language, they're bringing AI significantly closer to mirroring how we humans actually perceive and interact with our complex sensory world. The pace of advancement is frankly remarkable, and all signs point to continued rapid innovation in this space. It's definitely one to watch.
Okay, so here's the thought to leave you with, something to really chew on based on everything we've dug into today. As AI gets better and better at combining all these different kinds of information, seeing, hearing, reading all at once, and then using that incredibly rich combined understanding to create entirely new content that also spans those different types. What does that fundamentally change about how we interact with technology day to day? And maybe even, how does it start to shift our perception and understanding of reality itself, especially when you think about these capabilities being woven into real-time immersive environments like AR and VR down the road? Definitely something to think about.